Today we're going to be taking a look at some designs and talk about what makes a design a good design or a bad design and why. So make sure you have your notes document out that you started on the previous presentation and that you add notes and pauses as we go through. We're going to look at these four factors: economy, safety, functionality, and ethics. So starting with economy, some things to consider when you are designing a product is cost of material, amount of material used, and cost of labor. Cost of material, do you want to use metal parts or do you want to use plastic parts so they serve the same purpose? Maybe some photocopiers, for some manufacturers of photocopiers have changed from metal to plastic parts. Does it still function, or does that make it a bad enough design because of parts that need to be replaced that people don't want to buy those anymore? How about amount of material used? When you made your flat pack design, did you make all the screws the exact same size, or did you pick different size screws? If you pick different size screws, then that might mean that you have to buy multiple different parts. So it's not really very efficient to do that. It's a lot cheaper to buy one part, many of one part that are all the same size. Costs of labor. You may find a worker with experience and education that gives better quality work, but that also means they have a higher salary. So those are all parts to consider with economy. With regards to safety, there's a lot of restaurants, fast food restaurants, that offer little toys. So they need to be age appropriate when you're designing something. Does it meet that age requirement? Well, I guess for example, for that, is it something that would provide maybe a choking hazard? Because you wouldn't want to kill someone if they're eating at your restaurant. It's bad for business usually. Maybe another design idea is if you're designing a car or something, and where do you put the cup holders? Do you put them right above where the electronics are, the radio, or right below, so that if there's any issue of spill, it keeps the equipment safe? So that's just a design idea. It's not that it won't work if you put a cup holder right above the stereo, but it's just a bad design. It's not a design to keep the safety of the equipment in consideration. Now, looking at functionality, this might be an example of a toy that works awesome for the first 2 or 3 times, and then some of these gaskets start to wear out, or the plastic parts are really cheap and they break. So maybe it's not very durable, but what if it's a dollar store item? It doesn't have to last very long. Maybe it's for a little kid's birthday party, and it really only is supposed to have a lifespan of, maybe 20 uses. Then for $1, it might not be that terrible of a design if it's meant for that. If it's designed to be maybe a $20 toy, then you want it to have a lot longer lifespan, or people are going to be pretty ticked off when they spend $20 on something and it doesn't work more than 2 or 3 times. So determining what the function is, what it's going to be used for, is a big part of your design plan. Does it need to be durable? Does it need to have a long lifespan? If not, then you could probably go with cheaper materials. And then also looking at ethics. According to the Engineering Code of Ethics, engineers have to uphold and advance the integrity, honor, and dignity of the engineering profession. And they can do these by 4 different ways: using their knowledge and skill for the enhancement of human welfare, being honest and impartial with the public, their employers, and clients, so honest and impartial. 3, striving to increase the competence and prestige of the engineering profession. And 4, supporting the professional and technical societies of their discipline. So these are 4 different things, I guess, that the Engineering Code of Ethics indicates that engineers will uphold and advance. So if you want to relook at that, go ahead. They should definitely plan to make things that are environmentally friendly and safe as an engineer, design things in an honest way, a competent way, and a supportive way. And so these are 4 different things, just summative words that summarize, I guess, the 4 things that I've mentioned. So let's take a look at some design flaws. These are kind of fun to take a look at. I'm going to first tell you a little story about a door hinge mortise that I tried to do at my house. So I was trying to put these door hinges on, and to do that you have to carve out, you can see in the picture here, you got to carve out a little bit for the door hinge to work. Well, if it's a square door hinge, it's not that bad. So you could probably carve that out, but it's a huge pain to actually take a chisel and carve it. And it's really tough when you have a rounded corner, which I'll bet you most of your homes, your doors have rounded corner hinges. So to do that, I decided that I would go out and buy one of these things here. And this thing clamps, the door would clamp right in here. I'll show you a picture next. And then you take a thing called a router, and you route right in here. You kind of follow this path. There's these little guides. I'll flip it over. These little guide pieces here. and here. So it looks like this, again, if it's clamped to the door. And this has it already partially routed out, so you can see along this edge here. It gives you a nice rounded corner. You stick this thing here, it's the router. You stick that with that little drill bit, but it's got a flat end to it. And you kind of plop this into here, and then it follows these curves. So I know that's not the same thing as this, but this one shows the router, so that's why I showed that picture. So once it's done, you have this nice little mortise thing here, and you can put the hinge right in there, and everything is great. The only problem was I bought this thing from Home Depot. Let me go back to you. I bought this thing from Home Depot and paid like 25 bucks for it, and I knew that was going to save me a ton of time, so I was like, sweet, I'll buy it. It's worth 25 bucks. Because I had like 10 doors to do times 3 hinges, so I had 30 hinges I was going to have to hand carve out of there. Well, what happened was when I put the mortise on there, this little piece did not fit the hinge. It actually carved way too far out, which all had to do with the radius of this piece. It was the wrong radius. So I went to some forum and I was like, what is going on with this product, this Ryobi thing? And I posted that it didn't have quite the right radius. And I got an email back from the person who actually designed this part. They emailed me and they said, hey, I'm the engineer that designed that part. Can you tell me what's wrong? Take some pictures and send them. So I was like, what? So I took some pictures and I sent them out to him, and he said, okay, well, I'm going to redesign that part, and I'm going to get another one manufactured, and I'll mail it to you. And I was like, no way. So that is exactly what this person did, and they redesigned them, and they mailed me the additional parts, and actually, I think I had that backwards. The parts that he mailed to me are in there. These are the old parts, and I'll show you here. They have a slightly different radius, as you can see. And so this is the original, and it had a lot, I guess, smaller radius. So, and this one has a lot larger radius. So it's more of a circle than, or a bigger circle, I guess, than this one would be. And so anyway, he sent me the new ones. It worked awesome, and I could not believe that somebody actually read something that I posted that it wasn't quite the right size, and they fixed it. So that's an example of a design that really should have been caught. I mean, I don't know why they wouldn't test it before they actually packaged it up. But went back, probably realized that there was an issue, and was checking the forums and found mine, because I think it was a new product. Found it and then wanted to get some pictures. I don't know why they couldn't clamp it onto the door themselves and test it out. But anyway, all right, so let's take a look at this. Where is the design flaw in this? Maybe not super easy to tell. You got 4 burners here. How do you turn this burner on? Not the easiest to tell. These little dot indicators is really hard to tell because it's a blurry picture. Probably give you an indication. And my guess is that it's this one, but it would be a lot easier if you had maybe a couple knobs on this side, a couple knobs on this side, and the clock in the middle. And I'll bet you anything that your stove, if it's relatively new, it looks exactly like that. They might not be a knob right on top of each other, but I'll bet you that the ones on the left side control the left and the right control the right. What about this? Yeah, you've been at a door like this and you run into the side with the hinge and it barely opens, so you slam into the door. Yeah, that's pretty fun. So we don't know which way this door opens. Does it open this way or does it open that way? It's hard to tell which side you got to push on. What about this side? 2 pictures of a fridge. You got a handle here, you got a handle here. Which way do you pull to open it? There's no handle in the front. So the design is to make it look pretty. No handles in the front, but it's really kind of tough to know which way to open it. The reason they put them on both sides like this is so that you could actually take the hinge, which is on the left side, unscrew it and put it on this side. So you could actually change the way that it was opened, but you know, on first glance on this, if you're trying to use it, it's not really easy to see which way it opens. How about this one? You probably come on a door like this before. There's handles on this side and on the back side. So which way do you push or pull on this? We don't really know. You approach the door, you think you push it, and you slam into it and nothing happens. Or you pull it and it's a push door. So where do all of these issues happen? Right around the design stage. So you've designed some type of problem, maybe starting to brainstorm solutions. And really at that time, when you're brainstorming solutions, maybe research and generate ideas, that's kind of the time when you could identify if there's going to be a problem. So if the research has not been done enough to talk with people who are currently using some of these designs and what they want changed, you're probably not going to make it in the best way, and you're going to end up with one of these design flaws. What about this one? What's wrong with this one? One-piece dog collar. Huh? How do you get it on them? If you squeeze their head, then maybe you can pop it through. The other issue is that these spikes, it's all one piece from the inside, but this is not one piece. You can't make this all one piece, so it'd have to be manufactured separately, put together. It would probably make it way more expensive to do that. USB drive. If you have a USB drive like this, it's awesome unless you need to plug anything else in around it. And then this is so big that nothing else will fit. This slide would be really, really fun, except you would fly off the side and it's crazy steep. This is just a really terrible idea. Baby toy, I don't know, I guess if these pieces are big enough, it's not a choking hazard. But the fun part is once you put them in, you can never get them out again. So that's kind of a design flaw. This is a design, it's not really a design, it's just an idiot. When I was in Alaska, this is the back of a building. Rather than moving this electrical conduit up and over the door, they just decided to go right past the door. So nobody can pretty much ever use this door anymore, which I thought was kind of hilarious. When you are researching your own designs, don't be fooled by Photoshop. This is clearly not a real design. Somebody photoshopped this. There is no gun that points back at you. So you're going to be asked to actually find some designs. Make sure that you're not tricked by Photoshop or by mirrors, and that you find something that's legit. Don't just look for images. Actually click on the page and see if you can read about it to make sure that it's not a gag page or a joke. This one definitely is a joke, especially because they've etched in the word NASA into here. So when you're looking at bad designs, consider products that you may have already encountered in your everyday life and that you feel you've been affected by poor design considerations. So I believe that's it for this. You can go ahead and do the next assignment and start looking up some bad designs on your own.